Okay, for this video we're going to be talking about measures of angles and arcs on a circle, and this is where you guys we're going to be using a little bit more algebra involved with the definitions that we talked about on the first page. So what I want to do here in this first example, and I did provide you the diagram because I didn't want you to be bogged down in trying to make sure it was labeled correctly. What I want to do here is I want to see if I can find a relationship using algebra and geometry together on this circle. So I hope that you can see this straight line right through the diameter here. Remember that any angles that are on a straight line are going to add up to our magic number 180. So if I go ahead and I take those three angles that make up that 180 degrees, we've got 25x plus 3x plus 2x has to equal 180. If I add all those together, that's 30x's equals 180, and so that means my x value comes out to be 6. So if I'm finding the measure of angle AOD, then that's actually 25 is that angle, 25x, and we just found x to be 6. So we're going to plug that in and we get 150 degrees. Pretty simple. Then for part B, we're going to find the measure of angle AOE. So if we put 150 degrees onto our diagram here, and we keep in mind that a linear pair, or in this case a linear triple, if we went this way, 1, 2, 3 angles that added up to 180, we can also make a linear pair going this way on diameter ED, and in that case we're just simply doing a quick subtraction with a linear pair. So 180 take away the 150 that we just found gives me that the measure of angle AOE has to be 30 degrees. The next example that we're going to look at, this is one that's not in your textbook, but it's similar, using algebra again to find the missing measures here. And so we're going to use the idea of a linear pair, or in this case again triple. We've got three angles here that are going to add up to 180. So if we add all those pieces, 8x minus 4 plus 13x minus 3 plus 5x plus 5 equals 180 degrees. Then as I put this together, add my like terms, I actually get 26x's, and minus 4 minus 3 and plus 5 give me minus 2 is 180. And when 26x add the 2 gets me to 182, I divide by 26 and I do get an even 7 this time. So if I'm finding the measure of, in part A here, angle RTS, that's the outline of the 8x minus 4 angle, and we just found x, so it's going to be 8 times the 7 that we found for x minus 4, and that gives me 52 degrees. Evaluating that out. Then the measure of angle QTR. Well, I think you can see that angle QTR is going to be a linear pair with angle QTV because we've got this diameter RV here going on. So if I think about a linear pair, and the linear pair angle there is 20x, so 20 times the 7 that we know x is gives me 140 for that big angle QTV, and so QTR, since it's a linear pair, is just going to be 180 minus that 140, so hopefully you can get 40 degrees there. On to the next page, we have measures of arcs that we want to find. And I'll just remind you of what we said in the vocab video, that every central angle is always going to be equal to the measure of the intercepted arc. So first, before we go any further, I'd like you to go ahead and put in the arc measures on each one of these, the arc symbols, that is, by the way. And so remember that little m in front means measure. So if we're looking at the diagram here and we want to find the measure of arc BE, then that is going to be equal to the angle that cuts off that arc, which is the measure of angle BFE, and that is a vertical angle with angle DFA, and DFA is marked as 50, and so the angle DFA is also 50, which makes the intercepted arc BE right here. That has to be the same measure as the central angle that cuts it off. If we want to find the measure of angle CBE, remember that is a 3 points, so we expect it to be a major arc, but it actually isn't in this case, because you can see it's much less than what a semicircle would be. If we were to go all the way across to the semicircle, it would be right there. But we're just going from C to B through E, and that's what we want to find the measure of. So we already know that this measure of that inside angle is 50 degrees, and so arc CBE is going to put the 90-degree angle you see here plus the 50-degree angle together, and so we're going to get just a simple addition there of 140 degrees together. Last example, this is going pretty quickly, I hope you can agree. This time we do have a major arc, and it goes from A through point C all the way over to E. So notice that this diameter here, AB, gives me that from here to here we know is 180 degrees, and then we just have a tiny little bit more of an arc to add on to that. So 180 degrees is that semicircle across from A to B, and then add the arc BE that we found in the part A of this question. So add another 50, and we should get 230 degrees here. Pretty simple, I hope. Okay, moving on to our next example, the measure of the arcs in this picture here. We're told in circle P, the measure of angle NPM is 46 degrees. So NPM 46 goes here. We're told that that radius PL bisects angle KPM. So KPM is cut in half by that radius, remember. So I think that will help maybe a little bit if we put on those congruent markings there. And again, I forgot to, or couldn't type it in, so please go ahead and put in those manual arc symbols over the tops of the pieces that you're measuring this time. So we know that it bisects the angle, and then we also know that we've got our perpendicular OP is perpendicular to KN, this whole entire diameter, so we know that that's a 90-degree angle there. Okay, so let's go through this. If we're going to find the measure of arc OK, that's going to go from O over to K here, and I think you can see that that's the other side of my semicircle with my diameter cutting across with KN, so that's just got to be 90. If I want LM, that's here, I have a little bit of work to do, because I know this is a diameter, so I know this whole thing is a semicircle. So I'm going to take the 180 that I know that must be, and I'm going to subtract out the 46 that I already know. And when I do that, I get 134. But notice we've got a bisected angle there, so we need to cut that in half, and we get 67, and that's going to be the measure of my arc as well as my central angle that it is cutting it off, remember. So that's measure of arc LM as well. And notice this is all in degrees, you guys, as we're doing measures, okay? Whether it be arcs or angles. So this last one is JKO as an arc. And just a reminder, you need to go through those points in that order around the circle. So J to K, all the way around to O. And I actually think that the easiest thing to do here, let me just highlight this arc for you so you can see it a little better. If we go all the way around the circle from J through K and then all the way around to O, I hope you can see that really this is the opposite of taking the entire 360 degrees for the circle and then taking out the angle JO that we have there. or excuse me, the arc JO that we have there. So the question is, what is arc JO? Well, if we think about vertical angles, this 46 translates over here to 46 degrees. And as we know that this whole angle from KPO is 90, then that is going to leave a central angle here of angle JPO, kind of like if you were to think about a Pac-Man symbol, the mouth there is going to be left over 44 degrees. So I like to think of it about finding the measure of JKO as taking 360 and then subtracting out the 44 degrees. Of course, you can always get there with 180. So J to M, 180, and then add in the 46 that you had before, and then add in the 90 that takes you from N all the way over to O. And either way, you're going to get 316 degrees. So from here, please make sure that you go to the next video, which is talking about arc length instead of arc measure. And then after that one, make sure that you go ahead and finish off the on your own questions before tomorrow so that I can check those and see how you guys are doing. Thanks. Have a good night.